Yeah, let me turn this down. Okay, so Friday, I wanted to share a key with you, and it was kind of a challenge because I didn't want to put it somewhere where it would persist, because it was actually a private key and it gave you access to things. And so it occurred to me that we could solve this problem by implementing self-destructing messages. Messages that only last a certain amount of time. If I give you a link and after an hour that link no longer works, then I don't have to worry about somebody on the internet next week getting that link, right? Because it's self-destructing. It's like the tape player, it blows up, right? So we want to build something that implements self-destructing messages, okay? And we're going to build this together.
Cool.
And so I'm going to write code, and you're going to tell me what to write, and that's how we're going to build it.
What's that website where you can send text?
Snapchat.
Snapchat, right?
That's what I was thinking.
Yeah, so one downside of all these services is that you depend on them not actually saving the message. So you're completely trusting. They say they deleted it, but how do you know they deleted it, right? The only way you can really know is if you make it yourself.
Whereas in this case, you're only depending on Google Cloud Storage.
Well, that's why the
We'll
people
fix that problem in a second, but yeah.
that website that allows people to cheat, Ashley Madison, that the people who
Yes.
hacked it said they hacked it because they don't actually destroy messages.
That's
but
right.
they destroy profiles.
And I can tell you Snapchat has been, apparently the federal government has been like, yeah, no, they give us all the information. It's not deleted. So it's all a lie.
Yeah.
And you can't trust people. That's why you have to make it yourself. Okay? And so that's what we're going to do. We're going to make our own self-destructing. This is actually not that hard of a service to make. But okay, so how do we want to build this? Any ideas of how we can build a self-destructing message?
Well, store it. Well, depending on how important it is, you probably don't even want it on memory. But you can keep it in memory
Yeah.
and set the message, set a expiry time on it, and
Yeah. No, that's a great
expire time
idea.
periodically and make it when the expiry time's up.
So where can we get it in expire time? What service provides that?
Time.
Yeah.
There.
Okay, so that's one idea. We could use time. What we could do is make a service that has, say, a ticker. So I didn't talk about time ticker. I talked about time dot after. They like gives you after a certain amount of time sends a time on a channel. Well, there's a ticker that every so many seconds will send a time on a channel. And so we could implement in a Go routine. We could say go run this code, and every 30 seconds we could go see what's been expired and delete them, right? So that's the idea we could use with time, is that we can have like a heartbeat or whatever that goes through every once in a while and cleans up expired messages. So that'd be one way.
There's also some sort of cron service on App Engine.
We could do that, which we'll talk about later.
When you delete it, you really want to override it, right? Somehow? I mean, deleting doesn't just delete anything.
Yeah, we are kind of dependent on their services for some of this.
Well, because of the web, right? You send something to the client, that seems like the timing should be occurring on the client. So that would be like a clear interval or set time out or.
No,
Yeah, but
if your client doesn't
we're
want
storing
to
the message,
delete it.
so we can use
Oh, I get it. We're storing it.
memcache to do this. Where's the Go?
Just click on Python, replace Python.
Memcache has the ability to expire. So you have to give it an expiration time and it deletes things after a certain amount of time. So we could just use memcache, right? We could say, do this item and give it an expiration time, and then after that much time, it'll be expired and won't be there anymore. Okay, so memcache can implement messages that self-destruct with expiration. Make sense? Does it make sense?
Makes sense. Makes sense.
Okay.
Can we make messages that self-destruct with damage? Destroy messages around them as well?
Yeah, or the computer smoke.
That part
no,
would actually just increase the clock speed.
We could make a message that self-destructs in the sense that rather than giving it an expiration time, the first time it's accessed, it gets an expiration time. So it's sitting there, it's good for forever until somebody uses it, and then after 30 seconds it goes away. Right? Then it's really like a self-destructing message. As soon as you click play, the timer starts. So we could do that with memcache, right? We'd get it, and then we'd set it with the expiration, replace the old one with the new one, and then it would delete after 30 seconds.
But other than matching the mission to possible intro, that doesn't matter because it's already in the client. You might as well delete it right when it's accessed.
Yeah. Probably. So that'd be like the one-time use. It self-destructs immediately. So it sends it to you and then destroys itself. Okay. We could do that way. That's probably the easiest. Maybe we should do that. Okay. So we're going to use memcache. We're going to store it in memcache, and memcache will delete it for us by using expiration. Or we could use the data store and delete it ourselves, either with a timer or with just as soon as it's accessed, delete it. Right? We could do that. And so the idea here is that you're going to have a form. You type your message, submit. It's going to generate a link. That link you can hand to other people. As soon as the link is accessed, the message gets destroyed, or after some amount of time, it gets destroyed. Right? Make sense? So I'm going to be able to share a secret with you, but in such a way that I don't have to worry about if somebody next week gets that link, the secret will be gone. So it's a secret with a short time interval. Okay. And that's a good way to share private information over a semi-public network. And that's why Mission Impossible, but that's self-destruct. Sure. It's the same idea. Okay, so let's try that. I think what we'll do is we will implement sort of both of them. We will, the first time it's accessed, the timer will start. After a minute, the message will go away. Okay? But it's good until it's accessed the first time, because I think that's the kind of use we want. So how are we going to do that?
You have to get the message.
Yeah. So what's the first thing we have to do?
Make an input or whatever .yaml.
Yeah. So we're going to make a project. We'll call it Self-Destruct. Okay. And then what else do we need?
App.yaml.
App.yaml. Yeah, if you guys want to follow along on your own editor, it may make this make more sense. Okay, so I'm just putting the same application we've been using, version 1, runtime Go, API version Go 1, and so on. We're going to hand everything off to the Go app. Okay. So we'll make a routes.go. Okay, so now I have routes. What should I put in here?
You should have
Your root,
enter message.
a handle of each
One,
one.
right?
Your root. I don't know if you want to handle it, handle func, probably handle func, and then send it to some function.
Okay.
Maybe you need to show people all the possible messages they can choose from, or what they, or there's a link that they have, or
They'll have the link.
something.
We're not going to list them. That would be bad, because then anybody could get anybody's message.
Okay,
It's not totally private, but it's kind of private, right?
yeah,
It's like a link shortening service. You could guess other links, but there's no way to list them all. So handle index. All right, so we're not doing anything. I'll go ahead and just start this guy, just because we can do that. Okay, so it's ready to go. Not doing anything though.
so basically when somebody clicks on a link, you know, it's going to come to your site, your domain, and there'll be something / some kind of URL, and then based on that we get their message, right? So we need something to get the message.
I think you want to
Yeah.
host
We have to submit a message and,
I think you want to host a handle fund for //MSG/ and then you pick up the random message ID from there.
Okay.
And then handle fund for index should just be a forward to post message that
Okay.
takes a message and returns the URL for it.
That makes sense.
is there, so are you saying, Rusty, there's a place where people post messages?
You post the message in the index, you just type it in, it takes the message and returns a random URL, which you email
would
to
send
your
somebody.
secret
Okay, yeah,
Peter Graves buddy.
okay.
And Peter Graves goes in and clicks that link, which is message/random identifier that displays the message in
Yeah.
30 seconds.
So we need something that handles form submit and handle index.
Okay. So you're thinking we'll have something like and there'll be like say message rec.form value, right?
Yeah,
Something like that.
yeah.
Okay. So what do we want to do?
You store that. You store MSG and memcache. I think the way you finally defined it as store permanent.
So how do I do that? Does anybody remember? We can paste code into Scratch.
Create an item. Oh, do it in Scratch?
I mean,
Doesn't it have to be adjacent to store memcache?
it can be any string in store.
It should just be plain text with message ID or message content really at this point.
Or you can tell me. Either way, it's just sometimes it's easier to. It's kind of hard to communicate code verbally. But either way. So how do we store a message in memcache? We have the message. This is a string.
Whatever user we need to create a memcache item.
Okay. And we could look at the docs for that, right?
Key value and values byte.
Like this, right?
And you might as well generate your random key at your random URL key at this point before you
Okay.
post that.
So how do I
That'll be how it's
do
fetched.
that?
UUID,
Yep, that works.
new value, v4.
And this becomes key.string. So we'll call this item. What should the value be here? Right? It should just be message.
The MSG.
Everybody buy that? So we've created our memcache item. And what do we do now?
Memcache.add.
Okay. We haven't created a context, so we need to do that. CTX app engine.context.
Memcache.add needs your item.
Like that.
That loose up.
Okay.
And
The docs have it like where you're also checking for an error. So you're looking to see if the key already exists.
Yeah, so what's the difference between add and set?
Yeah,
so we need to handle the error here.
So should we use set instead of add?
No, this is fine, because the UID will be unique, so it doesn't matter.
Is that correct about add versus set?
That is correct. It just sets the keys randomly, it should never overlap.
Now you need to get to present form.
So we need to render the form. How do we want to do that? Do you guys remember how to render a HTML form?
Well, do you want to do it with a template or just right here inside and go?
Either way, we can do anything.
So the first thing that IOUtil is in there a writer that we can just write out, and the response would be what we're writing to, and then we could write the string with backticks of
Yeah, we could do that.
IO write string, there it is. And then we could just do the form tags, and all that.
Okay, so I have a form.
Text input, or just input, text.
The name should be,
Message.
Or message.
Form should have a method of post.
and then input types in. Okay, maybe let's put a label. No, actually, maybe this shouldn't be an input at all. Maybe it should be a text area.
Text that.
You can have a larger blob of text, right? Maybe not just one line, but
Yeah, text area.
so this approach of the way we're thinking about this probably doesn't work well for a file, because the file is too big. But it will work for small messages. But we want to be able to support not just like one line, but maybe less than a few kilobytes is fine. In our case, I want to share with you a JSON file generated by Google. A JSON file is less than 10 kilobytes. That's fine. This will work great for that. Maybe if it's more than 100 kilobytes, then we got to start thinking maybe I should be using Google Cloud Storage for this. But it'll fit in our memcache. Okay. So text area. So maybe we should look at it, see what it's doing right now.
Yeah, sounds good. Whoops.
Need a header. Text HTML.
That was the issue. It looks for doc type, and it was wrong. That actually turned out to be nice, because that's the kind of thing you'll never notice that this was bad. It just said doc type, didn't have HTML. But you'll have weird behavior on the page, like things will look wrong, and you're like, why doesn't this line up right? And it's because you're not actually in standards mode, you're in, early 90s mode. And so it's like, it renders everything wrong. And just kind of gets weird. It's like, what's wrong with it? The whole time it was just you forgot this. Anyway. So we have a message. Do I send a message? Nothing happened. Why didn't anything happen?
We are handling the input.
Well, maybe something did happen.
It should be in your memcache, but we haven't sent.
There's one item that doesn't list them.
You need your UID, do you remember it?
No, we never surfaced it.
I know.
So there's no way to know what we just did.
You can't list what's in memcache?
Is this
There may be a way, but Yeah, I don't think you can. In general, that's not how you're meant to use memcache, so.
Anyway, you need to redirect or to somehow display the UUID URL for the,
Okay,
to retrieve it.
okay.
So we got to create a URL and show that to the user that here's your URL to your secret message.
Yeah, the URL is easy. It's just /msg/UUID, but UUID is gone now, so we need to make another one.
And the message URL will be
http:// or no, I guess not /msg/ whatever value for key. Yeah.
and then we need to write that when the form is submitted.
It's kind of tricky, actually.
Yeah, post a different URL.
I could do it that way.
Do you want to tell them what it is?
But that's kind of funky, right? I mean, it told me at least, now I can go see if it worked, but, I mean, I'd have to like
You do
manually
post
go
versus
to-
get method get.
So this works, but the issue is that, no, it's, what I'm saying is what we're telling the user here is not very user-friendly. Like I have to like copy this and add it to the URL manually. That's super annoying, right?
Present it as a link. Well,
So I could do that. And then,
But how would we get the, because now they can have a link to their message. But as soon as we load that page, that link to their message is gone. And
Okay.
maybe they want to send the link to their
this is
message.
better, because now I can do that.
it's still relative, though, isn't it?
I think it'll add the,
In the web browser, I think it will fix that.
so that's good. That's much better.
So now you need a note that says email this to Peter Graves.
So the issue here is, I guess this doesn't matter, but there's this blank A. Who cares? I guess it doesn't matter.
Well, could you do post versus get? Because first, when the person's, no, because get will be the first time when you're asking for it. Post deals with it.
I think maybe you should just post it to a different URL where you pick up the
Well, no,
message.
yeah, that would work. Scroll to your top of this code here. Because you have, come down just a little bit. If request method equals post, where does that end? That if statement.
Alright.
So you could show it on the post because, and then you could put if request method equals get, and you could do the other stuff inside the get.
Oh, okay.
And so on the get, it will write out the form, and on the post, it will write out the results.
That makes sense. Now we don't need this anymore. Because now we have it right here. Right. Oops. So we could say
I gotta say, don't view it before you send it, because it will disappear before Peter Graves can read it. Unless you want to check for the same IP address for viewing, and everybody can view it.
where is it complaining about message? Oh, here. Okay. I'll buy that. And so now we have a separate form. So the first time we go to this page, we see that, we submit a message, we get that.
Cool.
Okay. So now we need to implement this. So what do we do?
Get the key out of query string.
Okay.
Key out of the,
How do I do that?
It's gonna be that split in. And the first one is a request. And then you got forward slash message forward slash, and then your item, so it's 1, 2, 3, so it'll be 3, no, 2 slashes, right? 2 slashes, third item, second
Uh-huh.
item.
Yeah,
the
that's
square,
where
and the square bracket
you
too.
have 3 blocks of text with the 2
Oh,
slashes.
3 items, second, okay.
Memcache lookup.
0, 1, 2.
Memcache.
Context and key. And check for error.
What do you want to
Do
do
you
with
set
this?
expire on the memcache as well?
So if there's an error, what do we want to do?
Not found. HP error.
Okay, so now we have the item.
Go to key. So we got the value out, right? That's what item is. That's the value that we stored. Item.value. Okay. So we could just write the value back to the browser with the IO, right? Response, right?
We can use write because it is a sliceify, so you can write directly. Okay, so let's see what that does. Cool, so it returns our message. Problem is, it always returns our message. It's not self-destructing. We need to make it self-destructing.
Set expire time.
Okay. How do we do that?
How
Looking
cache
in-
hash expires?
We can just delete it. Yeah, just delete it.
Okay, so we could just delete it. The way we do that, we'd say memcache, delete.
Context and the key. It returns the error.
Let's see if that works. Perfect. Just self-destroyed. It's gone. Burned itself up. But the downside of that is maybe the user clicked a link on their phone and like, oh no, I want to look on my computer. And they go to their computer and then they look at it and it's gone. And so,
Graves only have one tape recorder. He doesn't have options either.
but he had 5 seconds.
How do you get 30 seconds, right?
So maybe we want to give them a little bit of wiggle room here to be able to retrieve it beyond the first time, right? And so we could set expiration instead. I don't know if there's a separate. I think you just set it, right? So you just say item dot expiration. What do we set it to?
30 seconds is what you said. So time it now. I don't know how to do math on that plus 30 seconds. I don't know how to do that.
Because it starts in data as a time.
So this returns a time? You can't use math on the time object. You can't say This isn't Ruby. You can't be like +3.dates. Incidentally, I think that's one of the worst APIs, but it does allow you to do that. I just find that bizarre.
Time. Time.now plus, no. Time.add,
So we can use add.
yeah, but I can't see how they do it.
Duration.
Takes a duration.
So, 30 seconds.
How do we make 30 seconds? You think just 30?
No, because that remains.
You have to create a type duration.
You're right. That would be nanoseconds. 30 nanoseconds, right?
Can't you say seconds?
Time times time dot seconds.
There you go.
Time dots. Got it.
But that's not right anyway. That error says cannot use time.now.add blah 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 blah. Type time.time as type time.duration in the assignment. So what's the issue here?
You have to take time dot time instead of like time dot duration.
Time dot, this is returning a time. This is returning time 30 seconds from now. This is expecting a duration.
A duration.
Of
A duration.
30 seconds.
30 seconds. That's what we should be passing it, right? The now is implicit. So in memcache, it doesn't take a deadline, it takes an expiration time, it's a duration.
Oh, wait.
Okay. Now what do we do?
So duration is just 30 seconds, and expiration time is 10:34 on
That's right.
August 30th.
Yeah. Yeah, memcache expects an expiration, not an exact time. Not a moment in time. So what do we do now? So I've set an expiration on the item. What do I do?
Well, you're done, correct? Then I just run it and reload it for 30 seconds to see what
Okay.
disappears.
Let's see what happens.
Wait, I think you need music. Dun 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 dun. This video might get flagged. I don't know. My bad singing. It probably won't be like that. Sounds like no song we've ever heard.
Okay, so we got our message.
And now the timer has started.
I guess we just wait.
Cue Tom Cruise.
It's not gonna die.
We should put a stopwatch on my phone here. That can also be a useful thing sometimes. So if you're having to work with those kinds of problems, it's where you like have to physically time things.
Maybe we should have just put it in for less time and then tried it and then.
That might have been a good idea. I don't know when we started, so I'm going to go at 15.
So.
Well, you should reload it now. You should reload it before, because that's critical, that it's reloadable.
It's back.
Yeah, there you go.
It's still here. Why is it still here?
Do we have to wait about
Because it's still in memcache.
Because you didn't wait 30 seconds.
I did wait 30 seconds.
We didn't do anything when time expired. Oh, item expiration.
Oh, you need to relook it up on reload?
We did look it up.
Yeah, you do relook it up. Do you need to
It resets
you have to
the timer
re-put
every time you.
Yes.
the item?
The issue is we changed it here. We
Right.
never told memcache about it.
You need to re-put the item?
Exactly. And here we do want to use set, okay? Because it's
Override.
we're overwriting. Does that make sense?
Yes.
And is it okay if it's overwriting resetting the 30-second timer every time you email it?
No?
That's another issue. But let's see if this would work.
Wait, so it will reset the timer if you reload before the timer expires.
Yes.
That's probably not what you want, because then somebody can keep the message alive artificially. Right?
Right?
Yeah. So it's 5 seconds here.
Every 4 to 5 seconds.
Some buffer. 45 seconds.
True.
So it does self-destruct now, but we have the other issue, which is okay, I'm going to refresh. Now in 20 seconds, it's supposed to delete this message.
But every time you refresh it, repost it. So if you refresh, it just keeps restarting the timer.
That's right.
So do you want to have some sort of set time, set duration? You want to delete it, but then you have to check the time each time. That's nuts.
Yeah, so how do we want to prevent that? So I can artificially keep this guy alive by just refreshing the page over and over again. I want to make it so that as soon as you looked at it once, it's going to go in 30 seconds.
Could you check that property? Like if item expiration equals null or something, then
Perfect.
set it.
I think that's probably right. So if it's the first time, then we set an expiration. So
Feels like the first time.
all right, so let's try that. Test 4. Okay. In 10 seconds I'll hit it. And then I'll hit it again.
While we're waiting for this, I just have to share with you all that I'm big in China.
Yeah.
Like after we start putting up these Golang videos, I'm getting all these Chinese names subscribing to me on YouTube. Serious. I've got characters I can't even read here. And then there's Yang Bao and Dan Tran Trong and Lin Xing and Cao Yin.
Galaxy Go is really popular in China.
It's still there. So something's wrong. Right.
So there, so it's never getting set. So what is expires never equal to 0?
I don't know. So
What
why is
would
this
the null of expire be? So could we log that?
Thank you.
Here it is. Expiration is not set when getting items. It says in the docs.
There you go. See, you read the documentation, you wanted to log it, you guys are totally getting it now. You don't always know the right answer, you have to figure it out, right? Okay, so,
So what there is, though, is there is a flags field which is opaque to the applicant. It's
Okay.
just there for our use.
so what do we do? So you're saying we could do something else instead of this?
The flags in UN32 is just for our use. It's for app and app use. Your item.
Server thing, semantics are entirely empty. That's nice to know.
You can set that to 1 was the timer set. And then traffic.
So we don't know, we can't know. Because it doesn't, on Git, it doesn't set it. It won't tell you.
The flags, we can set the flags to 1 when we were at. We set the flags to 1 when we set the timer.
Okay, I don't know if that will work or not, but we can try that.
Well, let's see what the expiration is when.
Oh, well, it said right in the docs here,
Okay.
not set when getting items, so we would have seen that if we
Okay.
logged it.
Okay.
So both of those are the right, look at the docs or do some logging, both of those would get you there. Though there is a benefit to logging, which is that sometimes the docs are wrong. But in this case, I think we're fine. So this doesn't work because it's always 0, so every time I refresh it, it gets reset again and again. Because get doesn't set, it doesn't tell you what the expiration is. So that's kind of an issue, right? So Daniel's suggestion was we use flags. Something like this, and then we'd set it in here. Is that what you're saying?
Yeah.
So they call it flags, but it's only one flag.
It's a UN32. You can use each bit separately if you wanted to for 32 when moving.
Oh, so these are.
But
Remember that stuff?
you could do whatever you want with it.
Okay.
Basically, they give you a UN32.
The bit stepwise operators.
Okay.
We're just using it for one, so we can just do 0 and 1 here. Okay, let's see if that works. So the theory goes that the flags are stored with the message. So this is test 5. And that we get them back on the get. And so that by setting them, we should be able to tell the difference. Okay. So let me refresh. And then we wait,
30 seconds.
well, 20 seconds.
You could refresh every second and add 30th refresh.
We could do that. Oh, there, it worked. So Danny's suggestion worked.
What we're using to,
That's great.
what we're using to check expired form, item expiration.
Yeah, it's because it didn't fill it in for us.
What about,
But now it is, because this flags is filled in. It does come from the server. So we can check based on this flags whether or not.
what's the difference between expiration and get expires in seconds?
Sorry, what?
Set request item and
I don't see who get expires in seconds. But this works.
memcache get response item get expires in seconds.
I don't see who get expires in seconds.
Oh, I mapped into an internal memcache. Okay.
Yeah, we can't use that one. We can use
One
flags.
level too deep.
Another thing, if this didn't work, we could have stored it as part of the message itself. Maybe the first byte of the message would be this flag. But this totally works, so we'll use this. So now we have messages that self-destruct after a certain period of time, and so you can only view them once. Okay? Any questions?
Is there any way to make it refresh itself after it expires? So the message disappears?
JavaScript side.
That would be JavaScript.
Yeah, we could add code to the client to force a redirect after, a refresh after 30 seconds. Use location.reload. You can say set timeout function location.reload, comma 30,000 milliseconds. After 30 seconds, it would reload the page, and then the message would go away. Now, of course, they can do, once they have the message, they can write it down and do whatever they want with it. There's not much you can do to control that. And so you're just sort of assuming that the other side, of the receiving side of the secret message is going to at least try to keep it a secret. But the downside of this is always that the user can share the secret. And Peter Graves could have told somebody what the message was, right? But you're sort of trusting that he wants to keep it a secret. And so you're just protecting against a common mistake of accidentally leaving the message somewhere by deleting for them, right? So what are downsides of what we're doing here? This isn't, the security here has some issues.
We have trust that mentions memcache.
We're trusting that that's one thing, that's a problem.
UUID is, well, pretty good.
No, we're fine there, I think. The other issue is that if there is a way to list keys in memcache, okay? And so if I work at the company with a secret message telling thing, I can just go look at everybody's messages and read them, right? That's kind of crummy. I only want the person who receives the link on the other end to be able to read the message. So I want two things. I want the messages to be destroyed soon after the read, and then I also want the messages to only be read by the intended recipient.
Well, if you don't want admin to read it, then you're stuck sticking it in memory on that engine.
I think there's a way we can get the best of both worlds here, and I think we've talked about it already. Remember when we did cookies? And we wanted to store information that we didn't want the user to be able to read in their cookie?
Encrypted with a key.
Exactly, we can encrypt it. Okay? And we encrypt it, and then even we are not able to read the message because it's encrypted. And so, remember how encryption works? We get a message text and a password, and we run it through this special cipher thing, and it gives us an encrypted blob at the end. And the only way to read the encrypted blob is to have the password. Okay?
And you're going to transfer the key to the URL?
Right. So what I'm suggesting is we can use that key we generated or some other key as the password. Okay? So here's the idea. We have this key. Let's have a second key. And that'll be the password for the message. Okay? And so now we're going to have two keys. We're going to call this key the message key, and the other one the secret key. And we're not going to store the secret key in the message. We're going to store it as part of the URL. Okay, so we'll add at the end here. So now we'll have, the link will have the secret inside of it. But we never store the secret in memcache, okay? So now if we have some admin who has access to memcache, he can see all this data, but he can't read it because he's missing the secret needed to read it. And the secret only existed on this page for the person who copied the link. We didn't store the secret, okay? So now what we need to do is encrypt this. So instead of storing the message, we store the encrypted message. Okay. So how do we do that? Does anybody know how to do that?
Memcache has got a codec type.
Oh, there's an interesting idea. So codec represents a symmetric pair of functions that implement a codec. Items stored into or retrieved from memcache using a codec have their values marshaled or unmarshaled. So that would be one way. We could use this to do it. I think it would be easier for us to do this manually and then convert it into a codec if we wanted to. The idea of a codec is it would make more of a seamless API. So you could use this as if it were regular memcache, but behind the scenes we'd be doing the decoding and all that. But I think maybe as a starting place it'd be better to just do it manually. So there are lots of ways we can do encryption, and honestly doing your own encryption is probably a bad idea. And so this is a potentially dangerous operation.
ROT 13.
But, yeah, the high security ROT 13.
Go.org/crypto.
You use AES. This is one way, AES encryption. This is the standard high security encryption that's used for all kinds of stuff. Creates a new cipher. A key should be this many bytes. This is probably going to cause us problems to get right, because there's a lot of subtleties here. Incidentally, one of my favorite libraries in Go is this one.
Yeah, it's subtle.
Package subtle implements functions that are awful. I just think that's funny. They just called it subtle. They're like, there's a lot of things you have to get right in order to. If you get one of them wrong, the security's all busted. So there is a package called NACL.
You have NACL
NACL.
in your search term.
NACL. Isn't that what I want?
Oh, I thought you wanted ACL.
Oh, no. And we want, I think, secret box. Here we go. So there's the crypto libraries in the standard library. Then there's this additional one, golang.org/x/crypto, which has a bunch of other ones. One of these is this, NACL/secret box. and ACL. So secret box encrypts and authenticates small messages. It does so using, you could spend years these kinds of algorithms, but it's easier to use than what we were doing before, maybe. Maybe not.
Isn't that
So
sodium
it's the
chloride?
caller's responsibility to ensure the uniqueness of nonces.
Yeah. I don't know, maybe I shouldn't be showing you guys this. I mean, we could try it. It's just there's a lot of steps involved.
You'll have to kill us.
Encryption's a tricky subject. It's a hard one to get right. But the idea is that you'll call open for something that's already encrypted and seal to encrypt it. Okay. And so, yeah, maybe we shouldn't do this. I don't know. We can see how long it takes. It's not that bad.
It's an interesting name.
Open and seal.
NaCl.
Sodium chloride.
That's for Go's data client.
No, it's a general purpose library to make encryption easier to implement.
Salt, I get it.
Yeah.
But it's used very common in other languages as well. But basically the idea was getting encryption right is really stinking hard, so we're going to make a library that programmers can use to do it. So, although this is a little tricky to work with, it's not nearly as tricky as doing it yourself. Because there's all kinds of subtleties involved that if you get them wrong, it'll break. So let's try to do this. So we're going to make an open function, and what open will do, or let's just call it decrypt, you'll hand it the encrypted string, and it'll give you back a decrypted string. Now it can probably return an error. Oh, we need the password too. Okay, so you give it encrypted the password, and it returns the decrypted stuff, and then we need the corollary encrypt, where you give it the decrypted thing, the password, and it returns the password and an error. I don't know if you can really have an error, but the idea here is that we'll call encrypt on this side and decrypt on the other side, and that's how we can read the contents of our message. So to encrypt, we'll use secretbox.seal. Okay, so seal is what encrypts. It appends it to out. Out is a slice of bytes. And message is the incoming message. And then we'll need this other stuff. So we'll need out. And it returns the slice of bytes it creates. So actually, we can't have an error here. That makes sense. You can always encrypt. It's the decrypting which might fail. The decrypting will fail if it's a wrong password. Okay, so we need to create the out, which actually can just be nil. So we'll say encrypted secret box.seal. We'll give it nothing for out, so it'll just create a new one, and then messages the message. So we can get that like this. The nonce is a number used once. And the idea is that it's a unique number that you only ever use once. Okay. And this prevents what's called a replay attack. So we want to, the way we can do that, it says it's a 24-byte number. We can use, there's a crypto rand that can do that. So
Is that a 24 byte? Like I've seen a slice of bytes, but I haven't seen that 24. Is that a Go type?
that's an array.
That's an array, okay. Not a slice. So you get an array of bytes.
Yeah, so actually we say 24 byte. Okay.
I haven't seen that before. That's cool.
And then we say and it's 24. then we need a key. So for the key, it says 32 bytes right here. So what I'm going to do is, since this is how the 32 bytes are implemented, I'm just going to take it in here. So instead of a string, it'll be that 32 byte array. Okay. And then we will return it as a hexadecimal. Okay.
Why %X?
It's a hexadecimal format at the slice of bytes, you know.
Okay.
What am I missing here?
You're returning a hexadecimal instead of a string.
It's a hexadecimal string.
I keep thinking of that scene from Monty Python. I think it's Search for the Holy Grail, where he comes to the bridge. You know that scene? Yeah. And then it's like, he has to answer a question,
Yeah.
pass the bridge.
Answer 3 questions.
Yeah, answer 3 questions. The Europeans fall, the Eastern or the Western? I don't know.
Okay, so that will encrypt it. Now here's the issue. To decrypt it, we're going to need that nonce. It has to be the same one. Okay? The number we used once. To decrypt it, we have to use the same one. So the idea here is that the nonce is not a secret. It's not part of the password. It's part of what we pass along to the...
So that's what, when you talk about encryption, that's kind of like the key. This is the thing that locks it, this is the thing that unlocks it.
No. It's basically what we do is we take this, and put it with the message to ensure the message is never repeated. Because if you ever use the same message, you can use that to break through the encryption. So you're never supposed to encrypt the same message twice. And so by using this, we ensure the message is always unique. That's what we're doing.
Okay.
So we never see the same message twice doing this. That's it.
Okay.
And this is enough bytes that you can use random. You could also just use an incremented counter. This is message 1, message 2, message 3. You just have to make sure you never repeat it. And it tells you that if you do that, then people can break through and guess your key and stuff. So anyway, the point is we have to pass that along. So we have to add it to the encrypted string.
Do most people not know this, Caleb? Because if they knew this, then, you know, sites getting hacked, I feel dumb mentioning this site again, but like Ashley Madison, right? There's a recent hack. If people knew this, then that wouldn't be possible, right? Like if they hacked it, it'd just be a bunch of encrypted information.
Yeah. I mean, if software developers implemented encryption properly, the number of hacks we had would be far less. So that's absolutely the case. To give you a sense here, the PlayStation Network, when they got hacked and lost all of their user accounts, all whatever million of them, it was because they failed to use a nonce. They used the same number every time. So they forgot to do this, and it broke, and they lost everybody's information. So it's hard to get right, because you make one mistake and you'll never notice, because it works for you, and you never notice the security hole that's sitting in your code. And it happens all the time. I mean, OpenSSL breaks every 6 months, so somebody finds some new vulnerability in it that are devastating, you know. I think every single signed key for SSL was broken for like 5 years. They were all broken. They had to recreate all of them. Everybody had to make a new one. Cost millions of dollars. I mean, anyway. So I'm not saying this is easy. I'm just saying this is what, if you wanted to make it secure, you got to do this, right?
I mean, but it's not that hard. It seems like a lot of people don't know how to do it. I didn't know. You know, I mean, you know how to do it, obviously. Now I'm learning how to do it.
Kind of. The likelihood of me making a mistake very high.
Really?
Yeah, absolutely. You forget one thing and the whole thing's broken. I wrote one of these ones and I didn't do I didn't protect against the replay attacks, and I didn't even think about that. It's like, oh yeah. There's a thing called a side channel attack where if you compare two large strings, okay, so imagine you're trying to compare passwords. And so the way we compare two strings in a programming language is we start at the first character and we walk and we say, are they the same? No. Okay, we're done, right? We say it's not the same. the time it takes if the strings are almost identical except for the last character, right? So if I'm comparing,
Yeah.
if I have A, B, and I compare it to A, C,